Okay, now we're going to look at another type of factoring that's where you would factor perfect squares. Not a type of factoring, it's just like another pattern. And in math, when we find patterns, we put names to those patterns. But I just wanted to point out this pattern where we sometimes come across perfect squares. So if you notice that this is a square number and this is a square number, just like our difference of squares. However, we have a term in the middle. And if that term in the middle is the square root of this one, just 5, doubled, then you know you have a difference of perfect squares. So I know that when I factor, that has to be 5 and that has to be 5. And it's positive 25, so either they're both positive or they're both negative. But because I want positive 10, I'm going to put it there. So that means that my answer is a squared number. And that's what it means by perfect squares. It's something times itself. So if you FOIL it back, you would get that answer. This is just actually another reminder that in theory on tests for factoring, you should be able to get perfect in theory because you can always check your answer. So just what I mean by that is if I FOILed this, right, first x times x, outsides 5x, inside 5x, and last 25. Oh, well, I know that that's x squared. Oh, x squared plus 10x plus 25. So obviously I got it right because I expanded it. Now I say in theory because you could still make, math mistakes everywhere. Right? A simple multiplication error can change everything, but that's what I mean by in theory. You can always just double check to see if you factored it properly. So if we go to the next question, we have, fix that, okay. The same thing. So this is a square number, this is a square number, which means that I know that it's going to be x and 3 and x and 3. And we just have to decide if they're positive or negative. We know it's not going to be one of each because if it was, we would have had our difference of squares, right? So we know that it would have been both positive here because that one's positive. Okay, forgot my equal sign. Over here, this is a square number. This is a square number. So we know that's 3x, that's 3x, that's 4, and that's 4. And this is negative, so this one's going to be negative here and negative here. And we just double check to see if this is the case. And we've got minus 12 plus minus 12, which is minus 24, which is exactly what we want. Okay, and then this last one, this is a square number. This is a square number. It's 4 and 4. This is negative, so we're going to do both negative, and then we just double check. Minus 4x in the middle, and that's perfect. And I'm only checking the middle here simply because I already know by placing the x's in the front here, and then the x, and then the 4's in the back, that it's going to satisfy the first and the last value anyways. I'm really just checking the middle to see if when I FOIL it out and then I simplify, this is what I'm doing in my head. I'm going, oh, this is the middle and this is the middle, and they add up to that. Okay, that's what I'm just kind of explaining my thought process. So perfect squares sometimes happen, and you just notice them by looking at the first one and the last number to see if they are square numbers. And then you do the same thing as if you were doing difference of squares, but it's not 1 plus and 1 minus. It's both positive or both minus. I'm gonna fix this right here. That's perfect squares.